For problem number 8, we're told that in air, the speed of sound s in meters per second is a linear function of the air temperature T in degrees Celsius and is given by S of T is equal to 0.6 T plus 331.4. Which of the following statements is the best interpretation of the number 331.4 in this context? Well, I just want to remind you guys, linear equations, when I have a linear equation, remember the m is the slope, which is the rise over run, but sometimes we think of that as the rate of change. Okay? So that's how much it changes. But b, we refer to as the y-intercept. And the y-intercept, the x value is 0, so we also kind of think of this as what we call an initial condition. Right? This is where we start off at. So let's read through the options and see which one matches it the best. It says the speed of sound in meters at 0 degrees. That might work. Okay? Let's get to the next one. The speed of sound in meters per second at 0.6. No, probably not. Remember that the y-intercept occurs at 0, comma, whatever our function is. The increase, option C, the increase in speed and sound in meters per second that corresponds to an increase of 1 degrees. No, that won't work. The increase in speed in meters per second that corresponds to 0.6 degrees Celsius. No, that doesn't work. I think this is the one that satisfies it the most, right? And the reason I say that is when I say S of 0, my rate of change is 0.6. In other words, as my temperature increases degrees in Celsius, the speed of sound increases as well. Whoops, it's just 0.4. So when the temperature is 0 degrees Celsius, this goes away, and so this would be my y-intercept, which is also the initial condition. And I say that term loosely. Whoops, we'll just say initial. Because we're assuming that we're starting at 0. In most cases, we start at 0.